Now let's make a summary of the reporter's report. The reporters make a good qualitative attribution to the periodic movement, to the friction, to the problem of friction, and I believe that friction is essential to this problem as the reporter has discussed. Moreover, they use a non-split friction and Newton's second law on the disk, which can quantitatively measure and predict the movement of the disk, which I believe that this prediction can be, his prediction is sufficient to experiment. And moreover, they have experimental verifications on the outer diameter, the initial rolling angle, and the angular velocity of the shaft, which I believe that these parameters is essential to the movement of the disk, and I believe that these are important parameters. So now I'll make an evaluation of the reporters. So first, for his strengths, he had used the non-split friction to model periodic movement, which I believe that this non-split, it is good to use a non-split, but it could be further discussed. And moreover, they have used electric motor to ensure the constant angular velocity, which we can see that this is very important for the phenomenon of this whole process. And moreover, they have used experiment to verify some parameters, including the inner outer diameter, the initial releasing angles. And furthermore, they have a clear understanding of the reciprocating motion, and I believe that this is the important part. However, there are some deficiencies regarding this report. For example, they have insufficiently addressed some physics mechanism. For example, the rigid body mechanism. They have known that in this system, the disk is not rotating a fixed axis. But however, in their report, in their moment of inertia, they have used a scalar but not a tensor. So here I question their application of the use of the moment of inertia. And furthermore, they have not addressed the role of oil and friction. So if it's caused sufficient viscosity, so I would like to question about the reporter. Does this mean that if the shaft is porous enough, does it will have a similar effect when it's have the ring order if it just maintains the viscosity? So that this point I'm going to further discuss. Furthermore, there's no theoretical explanations for the quick turn after release. We just see a theoretical and a simulation from the numeric solvation. But I don't believe there's qualitative analysis for this explanation. He also did not mention the increase of the amplitude judging criteria of two kinds of motion in a non-split and flipping motion, and why Z is increasing continuously with the increased energy from the shaft, which I believe that this should be further qualitatively analyzed in our discussion. Moreover, we have inadequate experimental verification on the coefficient of friction. As we can previously discuss, that I believe that the non-split motion, he has also mentioned slipping and non-split motion, which I believe that in a non-slipping motion, this coefficient should be further discussed. The material of the disk has not been incorporated properly because in the problem review, they have told us to use a carbon disk, rather not a carbon disk. So what is the difference between two kinds of disks, which I further discussed? And the thickness of it, have maintained it to be 1 millimeter. But how would the movement or the pattern of movement will change when you increase the thickness of the disk? It should be discussed. Furthermore, there has an investigation on the energy transmission between the shaft and the disk, which I believe is important to determine the movement of the disk. And moreover, they not use the carbon disk as we previously mentioned in my question. Furthermore, the inner diameter is not twice as the diameter of the shaft. So I will describe the question. Well, in the problem review, it asks us it's roughly twice. So what does the roughly twice exactly mean? I believe it's the increase of the diameter may have other effects or other phenomena to the whole problem, which is to be discussed. Now I to invite the report up for discussion. Thank you.
Thank you.
So first, you have seen that the oil provides viscosity for its movement. So do you believe that oil, so that if it provides velocity to maintain the pure rolling between the disk and the shaft, do you believe that an extremely coarse shaft will cause a similar effect of this process?
The friction between the ring and the shaft does not matter whatsoever as long as it is in non-slip motion. If we change the shaft to a shaft that has like a friction coefficient of infinity, that will do nothing but change the maximum angular velocity of which the ring and the shaft will be in non-slip motion.
So do you believe that if the shaft is coarse enough in the surface, it will cause the similar phenomena of your explanation?
Yes, because it is in non-slip motion.
Do you think that? What is the primary difference between the oil and the solid?
So there is no like large difference in in my part of the theory, because if it is in non-stick motion, nothing matters. However, the oil is important before the non-stick motion begins. When you put the ring on the shaft, it is not non-stick motion to begin with.
Okay.
There is a difference.
Okay, I see. So, but for the first question will be that in the oil, there's liquid. So if there's liquid, it do not need to move in the same velocity as a rich body. So for example, if this moves at a faster velocity, if this moves at a lower velocity, at two separate boundaries, and therefore there will be a velocity gradient among this inner part. So do you believe that this, have you considered this velocity gradient in your modeling of the friction?
I did not model friction because friction is only a factor that only helps the non-stick motion. I do not see the point in your. I do not see what is important about.
So you believe that in this scenario, the behavior of liquid, of the oil and the solid are the same?
Yes. So I've mentioned that in my when I used the Newton's second law for Fc equals mz 2 dot. I was just like all the forces acting will conclude to mz2.
Okay, so I do not, don't disagree. I don't agree with this proposal because I believe that the use of the oil is a liquid and therefore may have a greater effect since the oil can have a velocity distribution along the two boundaries. So I believe that this effect would cause a so-called lubrication friction, which measures the friction as the following equations. So I believe that the use of these equations will help us determine the friction force regarding this.
I strongly disagree. I do not really care what these values are because those values, the net forces in the z direction will just be.
Okay, so let's move on to the next question because I believe that this is the central part of the whole problem. And next case, you have mentioned you use carbon but not cardboard discs. So what do you believe? So what do you think is the difference between these two parameters?
So when I use cardboard, I use laser cutters to carve the cardboard discs. But in those situations, it is very hard to make a smooth inner circle, and thus the cardboard disc kind of.
So what do you think this where it's not smooth? What do you think the result will cause?
Non-stick motion will not hold, but it would be virtually impossible to actually give a quantitative analysis in those situations where the ring starts to drop.
So I believe that this is important part since the cardboard disc can store oil inside and have another information around the side. So I believe that the use of cardboard disc should not be replaced by the carbon disc. So do you agree with that?
Well, what do you think would be the difference? Can I see your point?
There's deformation around carbon disc. The carbon disc is very hard. So carbon disc will not have an exact. Not have some of the features the carbon disc have. So I believe that this should be further investigated by using carbon disc, but not majorly the carbon disc. So furthermore, you have mentioned that there are three degrees of freedom in the system.
Yes.
So can you show me that why there's 3 degrees of freedom in the system?
I think I may have misphrased that. If you just think of the degree of freedom of the normal vector as just 1 degree of freedom, that there will be.
Okay, but however, to my knowledge, let's say that for a rigid body, there are 3 translational degrees of freedom and 3 rotational degrees of freedom. By the limiting of the shaft, this one must be subtracted out due to the constraint. So -1, and then it runs at 5. So I believe there's 5 degrees of freedom.
We have non-stick motion, and we have torque analysis.
Okay? But however, I can even mention your degrees of freedom according to presentations. You have phi, theta, and so on.
Sine.
Yes, exactly. However, there's 2 more degrees of freedom as you mentioned in the presentation. Alpha, which is angle between the vertical and the contact point.
That is sine. That is sine.
Okay. So just the use of psi and the use of z, for example, is as it translates around.
But by non-stick motion, we could calculate z over by
Yes. But do you
derivatives.
believe that the z is essential for the movement?
No,
It's
no.
degrees of freedom.
No. It is not.
But I believe that as it moves along z and you calculate the function between the as the variable z and function of time, I believe that the degrees of freedom in z is essential to be inputted in the theoretical analysis, and I believe that it would be considered as a degree of freedom according to this theory.
I could calculate the velocity in the z direction by a function of these 2 functions.
Okay,
I don't see your point.
And one more degree of freedom has calculated. Self-rotation is one more degree of freedom which the rigid body would have. But there will be like the angle of self-rotation which would be alpha to be incorporated in the system. And I believe that the use of 5 degrees of freedom is more sufficient and more scientific than the use of only 3 degrees of freedom to calculate the whole
I
series.
started with 5 degrees of freedom, and by using, I actually have omega there, and that would be similar to alpha, and just like,
Yeah, it should be counted as 1 degree of freedom, but now by simply stating it is omega, or it's an angular velocity. So I believe that use of 5 degrees of freedom is essential to this problem. So I'd like to move on to our next point, which would be that what is the working mechanism the reciprocation and the increase of amplitude. And it's the increase of amplitude. So can you verify, can you qualitatively analyze that?
qualitatively.
Qualitatively.
Okay, so you do agree that friction acts alongside the ring of the shaft? So
Yeah,
that
there's a friction exerted on the disc.
yes. So that would mean that the tilt of the disc would have attenuation over time.
Yes, exactly.
Yes. But it is very, very hard to find a qualitative like explanation for the relationships between the angles and the like displacement of the ring, and I could not find any explanation but for quantitative explanation.
For myself, I believe that the use of lubricating friction can help better understand the working mechanism, since the lubricating friction would cause velocity difference between the shaft and the disc. So that as the disc moves too slow, this friction would cause this rotation would cause the disc to accelerate around the z-axis, and therefore it will accelerate. As the velocity is greater, so that it will decelerate due to the friction, which has a trend to the velocity of the shaft.
I believe it is not that simple.
I believe this is good qualitative analysis. And furthermore, you have to say that there's only one contact point of your rigid body and the beam. So, you have ever considered the effect of thickness of the disc?
Well, I have said that I will only consider thin discs, and in thin discs, they're like, okay, so actually I cannot find, so like theoretically there should be 2 points, but because of the theta, because like the disc actually goes in this direction also, there is only 1 contact point, and even a 2 contact point, there will not be a very big difference because the moment arm of the 2 contact points will be very similar if the thickness of the disc is
okay, I see that. If the shaft has the same direction of shaft, it's fine. It could be modeled as a simple rotation. But however, if the disc has rotated around its axis, for example, like this, there will be 2 contact points in these 2 scenarios.
Oh, but I'm talking. What I just said was that the angle theta makes the disc actually like levitate on one axis, and I've experimentally seen that there's only 1
Okay,
contact
so
point.
I believe that in this scenario, this still will cause a significant difference in the gravitational potential, since if it's 2 contact points, it will be lifted up by some degrees, and therefore the gravitational potential may have significant effect to the movement, which is just caused by the double point contacts. So in this case, I believe that the thickness of the disc should not be negligible in his scenarios, like accounting for the movement of the disc. So do you believe it?
So like I actually calculated the angle. So like the angle psi, the angle that I define as psi, that would be this angle right here. That would be important for double point contact. And when I calculated the angle that is needed for double point contact,
Okay.
it was much smaller than my experiment.
Okay, thank you very much, guys. That was a wonderful discussion, but the time is over.
Okay, thank you.
And 1 minute summary.
So, thank you. I have first mentioned, so in our discussion, I have first mentioned about some problems regarding the problem review. The essence of the problem. For example, what does the O mean? It should mean a lubrication friction, but not as the rotation. Constant rotation at the contact point, and therefore and moreover the problem states carbon disc. So the carbon disc should be used as phenomena for now instead of the carbon disc. And moreover, he has selected a basic understanding of the degrees of freedom in this scenario. As we calculated by the equation on the left, we can see that there's 5 degrees of freedom, which should be further implemented in his theory. And moreover, he does not mention qualitatively how the rotation and the movement of this starts to work, so that this working example should not be further used. And the effect of thickness of the disc, which is considerable in his videos, as is about several millimeters should not be neglected. For a solid thickness and a double point, and the air resistance should not be involved. It should be calculated now due to the large surface area. So I believe that this should be calculated and involved.
Okay. Okay. Thank you very much. And questions from the team Singapore reviewer.
Thank you for the discussion. Firstly, to the opponent, do you believe that the coefficient of friction affects the ring's motion significantly?
Yes, because coefficient may have the important aspect of the lubrication friction. I will make.
Okay, thank you. So do you think the presence of oil will cause the ring to slip more easily?
Excuse me?
Do you expect the oil to cause the ring to slip more easily?
Yes.
Okay, thank you. So to the reporter, can you estimate the thickness of the oil on your shaft?
No, and that is not needed.
So is it very thin? Is the layer?
It's very. Oh, actually, I used WD-40, and it is 17 micrometers.
Okay, so to the opponent, do you still believe that this velocity gradient that you mentioned is important, and will it cause the slipping?
It will cause the velocity gradient, but however, it's very difficult to measure.
Okay,
but
okay.
It's important to the whole movement of the disc.
Okay, thank you. So, to the opponent, do you also think that the main reason for a cardboard disc is due to the deformation effects?
The definition effect will not be a very important aspect, but however, in your quantitative analysis, the deformation will cause a transition between 1 point and 2 points contact, and may therefore affect the movement in this
Okay,
transition
thank
procedure.
you. So, to the reporter, do you think that the cardboard ring versus your carbon ring, does this difference affect the ring's motion significantly in that case?
In my carbon rest, I could observe jumps, and I believe that those were not really mentioned in the problem statement. The problem statement does not want us to investigate those, so I made a smoother carbon ring.
So you're saying cardboard ring will jump?
Because that was due to technical difference.
Okay, thank you. So, do you, to the reporter again, do you consider the collisions of the ring when the ring tilts too much?
I cannot observe those situations.
Okay, so to the opponent, do you think this is important?
I believe the collision is very important by regarding the deformation and the collisions between the rotation and the size. So I believe this should be fully considered by either transition.
Okay, thank you. So once again to clarify, for the reporter, so your change in direction due to the ring's motion is not because of collision with the shaft?
Yes.
Okay, thank you. So to the reporter again, do you account for the thickness of the ring in your final theoretical model?
No.
Okay, thank you. So also to the reporter, how did you release your ring at the start of the experiment?
So the initial conditions are very, very hard to regulate. So I just measured it after some time so that it would be in non-slip motion. I did not regulate the initial.
Thank you. And did you account for air resistance in your model in any way?
The air resistance is actually included because that would just add sum up. The net force of all of those forces will sum up to m.
Okay, thank you. And to the opponent, do you think air resistance will affect the ring's motion in this case?
Yes, this is the thing, because we know that the surface area of the ring is very large, so it definitely affects the movement of the ring.
Okay.
Can I add on that?
Yes.
I believe that there will be a very, very small effect of air resistance because if there is angular velocity in the tilt of the ring in that direction, the air resistance in that direction will be smaller than the bottom direction. That would account for there will be no other.
Thank you very much. Time is over, and we have time for preparation for the review.